Hello to everyone. This is Shantar Kumar, Assistant Professor, Department of Mathematics, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. Today topic is the Fourier expansion of periodic function in a given interval. The length is minus pi comma pi. In previous class, we discussed whenever the given function is the limits are in between that 0 comma 2 pi. But today we are going to discuss the limits are in between minus pi comma pi. First of all, we are going to discuss why we are going to using the Fourier series. As you know that previously the Taylor series is applicable whenever the given function is a continuous function and also the differentiable function. But whenever the function is a discontinuous function, at that time we need to use by using the Fourier series. That means the Fourier series is which is involving in terms of sine and also cosine series. That means the periods are in between that 0 comma 2 pi. Why? Because the sine period and also the cosine period, the pi period function is the 2 pi value. Now we'll go to discuss that what is the Fourier series, and before going to discuss that is the Dirichlet conditions for the existence of the Fourier series of f of x is the condition. Here the Dirichlet condition is nothing but here these are the some of the conditions which is required to satisfy. One is f of x is a bounded function and f of x is a single valued and f of x has a finite number of maxima and minima in the given interval, as well as that finally that f of x is a finite number of discontinuity in the given interval. That means if it is satisfied these are the four conditions, that indirectly the function is satisfied the Dirichlet condition. And finally if you are going to discuss here, these are that f is a bounded and single valued and finite number of maxima and minima in the given interval and finite number of discontinuity in the given interval. For example, that f of x is a sine inverse x and which is not a single valued function, and f of x is a tan x and which is also not defined in the interval, there is a 2k plus 1 into pi by 2 for all values of k belongs to any z value. And finally, that f of x is also sine of 1 by x, which is also the infinite number of maxima and minima in the neighborhood of the given origin. That means here according to that f of x is a sine inverse x, tan x and sine of 1 by x, which is a not applicable for that the Dirichlet condition, it is not satisfied. Now we'll go to discuss in generally the Fourier series in the given function that is f of x. The limits are in between c comma there is a c plus 2l, and here the required Fourier series is f of x is equal to generally that is a naught by 2 plus summation n is equal to 1 to infinity that is a n into cos n pi x by l plus bn into sin n pi x by l is a value, where here the values are a0, an, bn are the Euler coefficients or Fourier coefficients, and here the value of a0 is equal to there is 1 by l integration of c to c plus 2l into f of x into dx, and an also that is 1 by l integration there is c to c plus 2l into f of x into cos n pi x by l into dx, and finally the value of bn also that is 1 by l into integration that is c to c plus 2l into f of x into sin n pi x by l into that is a dx. These are the Fourier series in generally in between that c comma c plus 2l is the limits. Now we'll go to discuss whenever the limits are in between minus pi to pi, that means we need to replace that c is equal to that is minus l. Therefore the given required the Fourier series is also f of x is equal to the limits are in between minus pi comma pi by replacement of c is equal to that is a minus pi. Therefore the required Fourier series is also f of x is equal to that is a naught by 2 plus summation n is equal to 1 to infinity and also an into cos nx plus bn into that is a sin nx is a value, where the value of a naught also that is a formula that is 1 by pi integration minus pi to pi into f of x into dx, and an is also that is 1 by pi integration minus pi to pi f of x into cos nx into dx, and bn is equal to 1 by pi integration minus pi to pi that is f of x into sin nx into dx is the value. These are the formulas for the limits are that is a minus pi comma pi. In previously we discussed the limits are 0 comma 2 pi. Now we'll go to discuss that one of the problem, find the Fourier series to represent e power x in the interval that is minus pi comma pi. First we need to observe the given limits are here that minus pi comma pi is clearly, and here the function is assume that f of x is equal to e power x. Therefore by using that f of x is equal to e power x and in between the limits are minus pi comma pi, Therefore, we need to write the required Fourier series f of x is equal to, that is a naught by 2 plus summation n is equal to 1 to infinity, and again a n into cos n x plus b n into sin n x is a value. And here the limits are c comma c plus 2l is equal to, that is a minus pi comma pi, and here c is equal to clearly minus pi, and c plus 2l is equal to, that is pi, and c is equal to, if it is a minus pi and automatically the limits are 2l is also, that is a 0, then l is also clearly the value of pi only. Therefore, by using here the values are a naught and also an and also bn also, that while we are going to using that given function, that is f of x is equal to e power x, therefore a naught is equal to, that is 1 by pi integration minus pi to pi e power x into dx. Here the integration of e power x is nothing but e power x. Here the limits are in between minus pi comma pi. Therefore, by using the replacement of upper limit as well as the lower limit, the solution is a 1 by pi into e power pi minus e power minus pi is a value. And now the conclusion of that a naught is equal to, that is after take the LCM and again that simplification, that is e power pi minus e power minus pi by pi is a value. Now we'll go to discuss that is a n value, that is 1 by l into integration of c to c plus 2l into f of x into cos n pi x by l into dx. Here by replacement of the limits, that is a minus pi comma pi, the value of a n is equal to 1 by pi integration minus pi to pi, that is e power x into, that is a cos n x into dx, where here f of x is equal to the given function is a e power x is a value. Now we need to using by the formula of integration of e power ax into cos ax. Here we know that e power ax by, that is a square plus b square into a cos bx plus b into sin bx plus c is a constant. By using this value, here the value of a is equal to 1 here and b is equal to, that is a n value. Therefore, by using the formula of integration by parts, it is 1 by pi into, that is a e power x by, that is a square plus b square is nothing but 1 square plus n square into, that is a cos bx plus b sin bx is nothing but 1 into the value of cos nx plus n into, that is a sin nx, by using the formula of integration e power ax into cos bx into dx. And here now we'll go to replace that in place of that upper limit, that is a pi value, and lower limit it is a minus pi. By using the upper as well as the lower limit, that is a minus pi, the solution it will be 1 by pi into, that is a value of, it is equal to, after replacement of x is equal to upper limit pi and lower limit, that is a minus pi, it is a e power pi by, that is 1 square plus n square into minus 1 whole power n minus of integration of e power minus pi by, that is 1 square, that is nothing but 1 plus n square into minus 1 whole power n is the value. Once again, after that simplification of here, that is a value is here minus 1 whole power n by, that is a pi into 1 plus n square into the value of here e power pi, that is minus e power of e power minus pi is a value. And now we need to find out the value of bn also. Similarly, the bn is also, that is 1 by pi integration of minus c to c plus 2l into f of x into, that is a sin n pi x by l into dx. And here also by using that limits are here minus pi comma pi, therefore 1 by pi into integration of minus pi into pi e power x into, that is a sin n x into dx is the value. And here also by using the integration by parts, that is a formula of integration e power ax into sin bx into dx is equal to e power x by a square plus b square into, that is a sin bx minus b cos bx plus c is the formula. And also here a is equal to the value of 1 and b is also the value of n. Therefore, by using that a comma b and also the using the integration formula, here the solution is a 1 by pi into, that is e power x by 1 square plus n square into the value of 1, that is a sin nx minus n into cos nx. The limits are in between minus pi comma pi. Therefore, the solution it will be that 1 by pi into, that is e power x, that is nothing but by using that 1 by 1 upper limit as well as the lower limit, it is a e power by, that is a 1 plus n square into minus n into minus of 1 whole power n, and minus of once again that by using the lower limit e power minus pi by 1 plus, that is n square into, that is a minus n into minus 1 whole power n is the value. And conclusion of here, the value of bn is also, after the total simplification, it is a clearly you obtain that it is a minus n into, that is a minus 1 whole power n by, that is a pi into 1 plus n square, as well as inside of the bracket, that is e power pi plus, that is a minus e power of minus pi is a value. Therefore, by using this a naught, an and also bn value, when we are going to replace the required series, that is f of x is equal to the value of here a naught by 2 plus summation n is equal to 1 to infinity a n into cos n pi x by L plus b n into sin n pi x by L, by using the whatever we completed, that is a naught, a n, b n value. By using all these values here, the required series, that is f of x is equal to e power pi minus e power minus pi by 2 pi plus summation n is equal to 1 to infinity minus 1 whole power n into e power pi minus e power minus pi by, that is pi into 1 plus n square into cos n x plus minus n into minus 1 whole power n into e power pi minus e power minus pi by, that is pi into 1 plus n square into, that is a sin n x is a value. Now we'll go to discuss one other problem here. The given function is a f of x. Here the given the two functions divide like that sub functions. One is a in between minus pi to 0, the value of minus pi, and 0 in between to pi, the value is the x. With the help of this, the f of x is the function. We need to find out Fourier series and also deduce that here the problem is a summation n is equal to 1 to infinity 1 by 2n minus 1 whole square is equal to, that is a pi square by 8. That means here we need to construct that Fourier series and also including the deduce the problem. That means whatever we obtain that final, that is a Fourier series, with the help of the Fourier series only we need to deduce the required solution. Therefore, while we are going to observing here, the limits are clearly, there is a minus pi comma pi, and the function is also given the sub functions, that is in between minus pi to 0 and also 0 to pi. Therefore, by using the first we need to write out what is the required series, that is f of x equal, that is formula. And before going to discuss here, we need to draw the diagram of here what type of that minus pi to 0 and also 0 to pi. Here clearly when we are going to observing here, it is minus pi to 0 is nothing but it is a value of minus pi, and also that in between 0 to pi is nothing but the function is a x only. Therefore, with the help of this diagram, then you need to discuss, it is a limits are c comma c plus 2l is equal to, that is a pi comma, that is a minus pi comma pi actually. Therefore, c is equal to, that is a pi, and pi plus 2l is nothing but minus pi. Therefore, that c is equal to, that is a pi, and 2l is equal to pi. Therefore, that c is equal to pi and also l is equal to pi. By using the diagram of here and also by using the given function, the formula it is a naught is equal to 1 by l into integration c to c plus 2l into f of x into dx, and also by replacement of all these l values and c values one by one, the equation is reduced to that is a naught is equal to 1 by l into 1 by pi into integration minus pi to pi f of x into dx is the value. Therefore, in between that minus pi to pi, the given function is actually, it is a minus pi to 0 is a value is a minus pi, and in between that 0 to pi is a value is a x is a value. Therefore, by using that according to this the values, by using the integration part, after that simplification, you obtain that clearly the value of here a n is equal to the value, and similarly a n also we need to calculate, that is 1 by l into integration c to c plus 2l into f of x into cos n pi x by l into dx, and here also by using the l value and c value. Therefore, the given function, that is a change it to 1 by pi integration minus pi to pi, that is f of x into cos n x into dx. Therefore, by replacement of in between minus pi to 0 and 0 to pi, while we are going to divide like that two parts, one is a 1 by pi integration minus pi to 0, that in between minus pi to 0, in this problem that is a value is minus pi, and again that in between that 0 to pi, the value is nothing but x is a value. Now, while we are going to observing here also that first term it is a pi cancel, the second term by using the integration part and again by using the upper limit as well as the lower limit. Therefore, the value of here you obtain that a n is a value, and similarly we need to find out what is the bn value. Therefore, bn is also 1 by l into integration c to c plus 2l into f of x into sin n pi x by l into dx, and here also by using the given function limits, that is a minus pi to pi, and also by using the function of f of x in between minus pi to pi, that is a minus pi to 0 and 0 to pi. When we are going to divide like that two parts, that is a 1 by pi integration minus pi to 0 into sin x, and again that plus 1 by pi integration 0 to pi into sin x, and here the function is a minus pi to 0 is the value is a minus pi, and in between 0 to pi the value is nothing but it is x only. Again here also we need to find out what is bn value. Therefore, after that simplification of bn by using that upper limit as well as the lower limit, the solution is a 1 minus 2 into minus 1 whole power n by n is the value. Now, after getting this is the a naught and bn values, while we are going to replace in the required Fourier series, therefore f of x is equal to, that is a naught by 2 plus summation n is equal to 1 to infinity a into cos n by x by l plus bn into sin n by x by l, by using here a naught and bn, and also the values are given function f of x is equal to, therefore minus pi by 4 into plus, that is summation n is equal to 1 to infinity, and also 1 minus 1 whole power n by, that is n square pi into, that is a cos n x, plus that is a 1 minus 2 into minus 1 whole power n by n into, that is a sin n x is the value. Because of here that an is equal to, that a naught is equal to minus pi by 2 and an is equal to, that is 1 minus 1 whole power n by n square pi, and similarly we completed already bn is also, that is 1 minus 2 into, that is minus 1 whole power n by, that is a n value. And this is a equation consider 1. By using this is the equation 1, we need to deduce the required solution, that is a pi square by 8 is equal to summation n is equal to 1 to infinity 1 by 2n minus 1 whole square. While we are going to observing here in this first part, the right side of the equation 1, that is a denominator n square is clearly, but whereas in the second part the coefficient of sine, the denominator it is n only. Therefore, for the required solution purpose, we need to remove that the second term. If you want to require the remove the second part, that is a coefficient of that term is sin n x. That sin is nothing but by replacement of x is equal to 0 and x is equal to 2 pi and x is equal to 0. By replacement of all those values, we eliminate, that is a value of sin. Because of sin 2 pi n pi is equal to 0, sin n pi is equal to 0, and sin 0 is also 0. Therefore, now we need to replace by using in the equation, that is x is equal to 0 simply. Therefore, from the equation 1, that is f of 0 is equal to, that is the right side is also clearly, that is minus pi by 4 plus summation n is equal to 1 to infinity, that is 1 minus 1 whole power n by, that is n square pi into cos 0, plus the second term is totally eliminated, that is removed, because of that sin 0 is equal to 0. Now by using this is the f of 0, first we need to find out what is the f of 0. Therefore, we need to calculate what is the f of 0 from the equation f of x. Therefore, it is a 0 is nothing but lies in between that minus pi to 0 and also 0 to pi. Therefore, according to that f of 0 is also clearly the value is nothing but it is 0 plus, that is minus pi by 2. Therefore, automatically that is a minus pi by 4. Therefore, 0. Therefore, at x is equal to 0 is the value is a 0 plus pi by 4 is equal to 1 by pi. And again, summation of n is equal to 1 to infinity 1 minus 1 whole power n by, that is a n square. Therefore, here after that take the LCM and again the cross multiplication, the value of here, that is a pi by 4 is equal to 1 by pi into 1 minus 1 whole power n by 1 by 1 square plus 1 minus 1 whole square by 2 square plus up to so on is a value. Therefore, once again after the simplification of here, you obtain that cross multiplication of here pi numerator and denominator. The value of here, it is nothing but pi square by 8 is equal to, that is pi square by 4 is equal to, that is a 2 by 1 square plus 2 by 3 square plus, that is a 2 by 5 square plus up to so on is a value. Now we need to once again that take the numerator, it is the right side is a 2 is a common thing. Take that, take out common 2. The remaining part is 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus up to so on. And once again after the simplification of here, that is a pi square by 8 is equal to, you obtain that clearly, that is a 1 by 1 square plus 1 by 3 square plus 1 by 5 square plus up to so on. Now we need to write in the summation terms, that is a pi square by 8 is equal to, there is a summation, that is a 1 by, that is a 2n minus 1 or 2n plus 1. If it is a considered 2n minus 1, that is n is equal to 1 to infinity, it is a 2n plus 1, the denominator if you want to write, that is a n is equal to 0, you need to consider. Therefore, it is a final solution of the given series by replacement of x is equal to, that is a 0. Therefore, further, that is a Fourier series f of x is equal to, that is a a0 by 2 plus summation n is equal to 1 to infinity a into cos n by x by l plus b into sin n by x by l, provided by using that a0 and also n value. The value is nothing but, that is a pi by 2 plus summation n is equal to 1 to infinity, that is 2 by pi into, that is a 1 minus 1 whole power n by n square into cos n x, that is a total value. Now we need to discuss one other problem. It is find the Fourier series of f of x is equal to x plus mod x in between minus pi is less than x is less than pi. Here the function is clearly f of x equal to x plus mod x, and L is also the interval is a pi. Therefore, with the help of the formula of a naught and also an and bn value, therefore it is clearly a naught is equal to 1 by pi L integration minus L to L f of x into dx. Here the function is a clearly that is 1 by pi integration minus pi to pi. It is a function is a x plus mod x into dx. Therefore, it is a after the simplification it is a that is 1 by pi integration of minus pi to pi into x into dx plus 1 by pi into integration minus pi to pi, that is mod x into dx. Therefore, here x is the first one, it is odd term, and mod x is it is an even function. According to the properties of it is odd and even together, that first part whenever the limits are in between minus pi to pi, that is odd function, the value it may be 0. That you know that according to the standard formula, it is minus c to c, that f of x into dx is equal to 0, and whenever the function is a odd function. And similarly, whenever the function is even function, you need to replace that is a 2 into integration of c, that is f of x into dx, whenever this is the function is a even function. Therefore, by using the concept of here, it is a the first function it is odd function, it is a 0. The second function that is a even function, you need multiplication with 2. But here that c is equal, that is a pi value. Therefore, that after the simplification of here, the value of a naught is equal to the value is a pi is a value. Now we need to discuss the value of that is an. And similarly, that an is also that is equal to 1 by L integration c to c plus 2L into f of x into cos n by x by L into dx. By using the formula of here, that is 1 by pi integration minus pi to pi, that is a here the function f of x is equal to x plus mod x into cos n x dx. And once again, we need to divide like the two parts. One is a 1 by pi integration minus pi to pi into f of x into that is a cos n x into dx, plus 1 by pi into integration minus pi to pi, that is a mod x into that is a cos n x dx. And here also that first part in these two parts, therefore one of the part is in between minus pi to pi, that x is odd, that cos n x is even. Therefore, the product of odd and even is also that is an odd function. Therefore, entirely in this first part, that is a value is equal to that is a totally it is odd function. Therefore, the value of it is nothing but therefore totally together it is a 0. And now we need to find out, consider that is the second part, it is a mod x is a even, and again cos n x is also that is even. The product of the two even is equal to also that is even. Therefore, by using the formula it is a 2 by pi integration 0 to pi, that is x into cos n x into dx. Now we need to find out the integration by parts. By using the integration by parts, that is a 2 by pi integration of that is x into that is a sin n x by n, that is isolate or liate, minus 1 into that is minus cos n x by n square, that is integration of uv is nothing but uv dash minus v dash, or isolate or by using the liate. Therefore, once again we need to replace by using the upper limit as well as the lower limit. Here the value of that is a 2 by pi integration of that is a 2 by pi into that is a 0 plus minus 1 whole power n by n square minus of 0 plus 1 by n square. Because of, as we know that the value of that is a sin n pi is equal to that is a 0, and also that is sin 0 is also 0. And moreover here that cos n pi is equal to that is a minus 1 whole power n, and also that cos 0 is also the value of 1 only. By using all these values, while we are going to replace in this part, the equation is obtained, that is a 2 by pi into minus 1 whole power n minus 1 by that is a n square. Now we need to find out what is the value of bn. Similarly, therefore bn is equal to that is 1 by L integration of that is a c minus L to L f of x into that is a sin n pi x by L into dx. And here also that limits are minus pi comma pi. Therefore, by using here that is 1 by pi integration that is minus pi to pi x plus mod x into that is a sin n x into dx. And once again we need to divide like the two parts. One is x into sin n x into dx, and another part is a mod x into sin x dx. And here also that x is a in that first part it is x is a odd, sin n x is also odd. Therefore, the product of two odd is called also that is an even function. Therefore, by using that first part, it is a 2 into integration of 0 to 2 by pi into integration of 0 to pi, that is x into sin n x dx. And in the second part, the limits are minus pi to pi, but it is a that mod x is a even, that sin x is odd. The product of odd and even is also nothing but it is an odd function. Therefore, the second term it is clearly that is a 0 by using the property. Now we'll go to discuss once again by using the integration by parts, by using the Leibniz formula or Euler or Liet by using, and here also that solution is a 2 by pi integration x into minus cos n x by n minus 1 into that is minus sin n x by n square. The limits are 0 to pi only. And once again here also by using the formulas are, it is a cos n pi is equal to that is a minus 1 whole power n, and cos 0 is also the lower limit, it is a 1, and also by using the sin n pi is also the value of 0, and which is equal to sin 0 is also 0. By using these are the four formulas, when we are going to replace here, after that simplification you obtain clearly that is a 2 into that is a minus 1 whole power of n plus 1 by n is a value. After that getting these are the a0, a and bn values, while we are going to replace in the required Fourier series, that f of x is equal to clearly that is a0 by 2, that is nothing but it is a formula x plus mod x is equal to that is a0 is a pi, therefore pi by 2 plus summation an is equal to clearly we know that there is a 2 by pi integrate that is a minus 1 whole power minus n minus 1 by that is n square, and with the help of similarly the bn value also, the final solution is a x plus mod x is equal to the value of pi by 2 plus summation n is equal to 1 to infinity that is 2 by pi into minus 1 whole power n minus 1 by that is n square into cos n x plus 2 into minus 1 whole power n plus 1 by n into that is a sin nx is a required solution. Now we'll go to discuss one other, that is f of x is equal to the function is a 1 and also 0. The limits are in between minus pi to 0 and 0 to pi, and as a periodic function is a 2 pi. And here first we need to draw the diagram of that in between the function minus pi to 0 and 0 to pi. And while we are going to draw the diagram of here, it is the showing according to this is the structure. In between minus pi to 0 is 1, and again the 0 to pi is that is value is a 0. Therefore, next we need to find out that is find the Fourier series for that is f of x. Therefore, we need to find out what is the a0 value. Therefore, by using the formula 1 by pi integration minus pi to pi f of x into dx, by using that here, the limits are in between minus pi to 0 is one part and 0 to pi is also another part. Therefore, by using the sub two parts, the value is clearly after dividing that is 1 by pi integration minus pi to 0 is the value is 1 into dx. In between that 0 to pi, the value is f of x equal to 0. Therefore, that is a 0 into dx. Here, by using that here integration part, the first part it is a 1 by pi. Integration of 1 is x. Therefore, by using that minus pi to 0 limits, the value of 1 by pi into that is a pi limit. Therefore, here the value of a0 is equal to 1 only. And similarly, we need to find out what is an by using that 1 by pi integration minus pi to pi f of x into that is cos nx. And here also we need to replace by using that in between minus pi to 0 and again the 0 to pi the limits. Therefore, in between minus pi to 0 the function is a 1, and in between that f of x is the function is a 0 to pi is a value is f of x equal to 0. Therefore, the second part is totally that is at 0 only. By using that single first part, by using the integration cos nx is a sin nx by n. Once again by using the lower limit and also upper limit, that entirely the value of n is equal to also 0. Now we need to discuss the value of bn. Therefore, bn is equal to that is by using the formula 1 by pi integration minus pi to pi f of x into sin nx into dx. Therefore, once again we need to divide the two parts in between minus pi to 0 and 0 to pi. Therefore, by using that in between 1 by 1 all the values, that is 1 and also together 0. The second part it is totally 0 into something is 0. Therefore, it is by using the first part that is sin integration is a minus cos nx by n. In between the limits are minus pi to 0. And here by using that upper limit and also the lower limit, the value of bn is nothing but it is clearly minus 1 by n pi into 1 minus 1 whole power n is the value. Here depend upon the right side 1 minus 1 whole power n is nothing but two cases occur, that is a even function and also odd function. Because of that minus 1 whole power n is the depend upon the categories even and odd, you get that plus and also that is a minus 1. Therefore, the value of bn is the that is 0, that n is a even, and minus 2 by n pi is a n is equal to odd is a function. Therefore, together a0, an, bn values by replacement of in the required Fourier series. Therefore, the series is obtained f of x is equal to 1 by 2 into minus 2 by pi into sin x plus 1 by 3 into sin 3x plus 1 by 5 into sin 5x up to so on. Because of that bn value is a n is equal to that is even value, and moreover the value of an is also that is a zero value. And also we need to find out what is the f of x, that at x sin x is equal to 1 and sin 3x is equal to minus 1, sin 5 is equal to 1 and sin 7x is equal to that is a minus 1. The first term it is 1 and suggesting like that x is equal to pi by 2. By using according to that is a plus minus alternate it is a plus minus. Therefore by using all this value and similarly that x is equal to pi by 2 also, the conclusion of here, the solution it will be after that simplification of that alternate series, that is a 1 minus 1 by 3 plus 1 by 5 minus 1 by 7 up to so on is equal to that is a pi by 4. After that cross multiplication with 2 by pi and also 1 by 2 is a value. That means this is the conclusion of here. Whenever the limits are in between minus pi to pi, we need to find out according to the limit values are a0, an, bn that depend upon the given function, whether it is a single function or any sub dividing the sub functions. We need to follow with the help of the working rule only. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.